So just like we're always doing, we're gonna add more stuff to our arsenal so we can solve more advanced type of math. So today we're gonna be learning about the cosine and sine function, or the sine law, cosine and sine law. Probably heard about this in grade 10 and 9. They probably introduced it, but today we're gonna finally show you the entire proof. So in this triangle ACD, which is the little right triangle here, so the h divided by b is equal to sine c. So that is just a SPECTATOR. So sine c is equal to opposite over hypotenuse, which is h over b. That makes sense. And then to isolate for the height, it's supposed to be b sine c. So we're looking at it and we're like, okay, yeah, that works. And I want you to confirm this. Everything follows your understanding. Now let's look at the other triangle, ABD, which is just next to ADC. So if you cannot see, and if you're unsure, just confirm with me that the height does not change. So they're the same thing. So technically we can set them equal to each other. So if h equal to c sine b and h equal to b sine c, we can technically set them equal to each other because they're the same. Correct? So when we set them equal to each other, we want to kind of get rid of the thing in front of it. So if to get rid of the c, we divide it by c. To get rid of the b, we divide by b. However, we can't just divide it by c on the left and divide by b on the right. We have to divide by the same thing. So essentially, we're going to divide both sides by b and c. So overall, it's going to simplify to sine b over b, sine c over c. There's a variation of the sine law where it goes, you're putting the b at the top. So you're doing this, b over sine b equal to c over sine c. You're absolutely welcome to do this. There's literally no difference between them except for flipping them. Because if you just take the inverse, if you take 1 over, so 1 over the left and you 1 over the right, so there's literally no difference. They're mathematically the absolute same. So it doesn't matter which you use. If some of you might be more comfortable with putting the angles on the top, so that's why the textbook automatically did that. But if you're more confident of putting the angle at the bottom, go ahead and do that. So on the right, we have the cosine law. So in the angle ADC, which is a right angle here, we're going to go look for x. So x is this little part. And this entire big A, this small a, is x plus a minus x, essentially. So x is equal to b cos c using the cosine. Using the cosine c, which is the so cosine equal to adjacent over hypotenuse. Right? And then in this angle of ABD, c squared equals h squared plus a minus x, right? That is the Pythagoras theorem. Now, we can actually go ahead and expand that, and after expanding it, we're able to go ahead and substitute b in there. Because look at it, h squared plus x squared. What is that? That is this plus that. So that is literally just b squared, right? Because we're doing the Pythagoras theorem again. So we input that in there, and finally we have this cosine law, which is over there. So the cosine law usually comes in the format of, I'm going to write it out here, a squared is equal to b squared plus c squared minus 2bc cos a. So essentially, for the side, you're trying to use this to find an angle, to find a side, or to find the angle, or pretty much you can find anything in there. So if you're using this to find anything, you're going to isolate for it. However, this a right here, it must correspond to, well, the angle. For example, I can only be trying to find the side A if I have the corresponding angle. I can't find side B if I have the corresponding angle of side A. So I just want you to keep in mind that, and that's something really important. So let's go ahead and do some sine law and cosine law practices. So I have already drawn the image out for you. So you're going to have to do this. So if you don't want to if you want to have yourself have yourself drawing out a diagram, go ahead, go look at the practice questions on the textbook and try drawing on diagrams. So let's see. Where can we apply the sine law? So let's take a moment to look at this for a second. And we're trying to see what we want to find. So obviously we want to find this side, the side on the left, which is this side right here, right? So what we're going to do is actually we're going to first find the missing angle, because we all know the inner angles adds up to 180, right? So 180 minus 46 minus 21, that's going to go ahead and give us 113. So we know that sine of 113 is over 46. This corresponds to this set. And the other set that we're trying to find is 21 and the small t, right? So now, remember I said this at the start, we're going to use the n rule. So sine 21 times 46 divided by sine 113. Let's go ahead and calculate that. So sine of 21 degrees times 46 divided by sine of 113 degrees. So for me, I have gotten an answer already, but I just want to wait for you guys if you guys want to do it on your own calculator. So if you didn't get it, if you didn't get the same answer as I did, please check where you did it wrong and check what happened. So my answer is 17.9. 17.9085. There was a lot of it, but however, it asked it to round to the nearest centimeter. So I'm gonna go ahead and round that to 18, if I'm not wrong. So wait a minute, I just did something wrong, right? 180 minus 40 minus 21. Yeah, it's supposed to be 119. So this part was supposed to be 119. See guys, I made a little mistake. It's a calculator error. 119 over 46 over 46 is equal to sine of 21 over t. So now we still do the same thing. And then we do that, so you're supposed to get 19 cm. So you round up to 19. That was that. And now let's go ahead and do this question. So in PQR, we already see a pair, so it's going to be easy for us to find. So we have to solve the triangle, meaning we have to find every missing point. So let's go ahead and do this. Sine of 105.2 over 23.2 is equal to sine of r over 18.5. Right? So now what we're going to do is the same rule, but except for we're going to do 18.5 multiplied by sine 105.2 divided by 23.2. So let's do that. 18.5 times sine of 105.2 degrees divided by 23.2. Now this is not your sine, this is not your angle yet, because you have sine of r is equal to this number. So we're going to go ahead and do inverse sine of the answer, and you're going to be able to get an actual value in degree. So in my case, I got 50.3. So it asks us to round to the near tenth of a degree. So we have 50.3. Let's go ahead and write that in. So r is equal to 50.3 degrees. Now we have all the inner angles. We're gonna go ahead and find q. So q, let's just do 180 minus 105.2 minus 50.3. That's gonna give us 24.5. So q is equal to 24.5 degrees. Alright? And then let's go ahead and use the sine law one more time. So sine of 24.5 over small q. It's gonna go ahead and equal to sine. It doesn't really matter which one we use, but I recommend using the given ones because we don't want to be dealing with rounding problems. So we go ahead and do this. So sine 24.5 degrees multiplied by 23.2 divided by sine of 105.2 degrees. That's going to go ahead and give us a number, which is 9.9696, and we're going to round that up to 10 centimeters. So let me erase all of this. Q is equal to 10 cm. And that is the entire triangle solved. Now let's move on to application of cosine law. So remember the cosine law. Oh, I deleted it. It's okay. So if we remember the cosine law, it's going to be a squared equals to b squared plus c squared minus 2bc cos a. So let's see what we can use this on. So we want to solve the triangle, basically finding the inner triangles. So we can use one cosine law, and then after that we can use some sine law, right? Let's go ahead and do that. So let's say I just want to find angle A. Right, so I'm going to go ahead and be like the corresponding angle to A, which is 9.6. 9.6 squared is equal to B squared plus C squared. So 14.7 squared plus 20.6 squared. Now we're going to minus all of that. Minus 2 times 14.7, 20.6, and cos A. So let's see how that plays out. Let's first, you know what? First, let's simplify first so we can move some numbers around. So 9.6 squared is going to give you 92.06, 92.16. And we're going to minus a 14.7 degrees, 14.7 squared. And we're going to minus a 20.6 squared. So essentially on the left, you're supposed to have negative 548.29 equal to, so we're going to multiply these three numbers out. Let's go ahead and do that. So negative 2 times 14.7 times 20.6. I'm going to go ahead and get negative 605.64 cos A. So now let's divide this left side by this. So negative 548.29 divided by negative 605.64. It's going to give you a decimal number. And then we do the inverse of that, inverse cosine of that. We're going to get, for me, it was 25.135. So I'm going to go ahead and write that out. 25. So to the nearest tenth of a degree. So it's going to be 25.1. So let's go ahead and do that. Not right. Big A is equal to 25.1 degrees, right? And then let's go ahead and check what we do for the rest. So we have A here. We have big A, which is corresponding to 9.6. So let's just go ahead and sine law already. So you're absolutely welcome to go ahead and use cosine law for the other one, but really, which is recommended, by the way, because that is all the given values. But I just hate doing this, so most of the times I want you guys to go ahead and use the cosine law, but I'm not going to do that because there's going to be a lot of filling. But please do not worry about time management because you have a load of time during your tests and quizzes. So let's go ahead and do that. So I'm going to do 20.6. multiplied by sine 25.1 degrees. Then I'm going to divide by 9.6. And I'm going to inverse sine to that. That is going to go ahead and give me, let me check, 20.6 times sine of 25.1 degrees divided by 9.6. Inverse sine of answer. Okay. Okay. So for B, we're going to actually get 114.3. So your calculator might say a different answer, but I want you guys to think about why does it do that. So for most of us, we should have gotten some value like 65. However, I want you to use the identities I taught you last class. So 180 minus 65 or something, whatever answer you get, you're going to get 114.3. Hey guys, this is why I did the sine law. So this is a great chance for us to understand how correlated angles and related angles work. So guys, go ahead and do the 180 minus the angle that you got, and you're going to have this B. So sometimes when you do word problems, it's always good. Well, when we draw a diagram, it's always good to think about, hey, look, this is an obtuse angle. There's no way it's gonna be 65 degrees. So let's convert it and be like, yeah, that works. So B. Angle B right here, this is 114.3. And then lastly, C, we can just do the Pythagoras theorem, 40.6. Well, not the inner angle theorem. Finally, let's move on to question number 4. Find the length of a CD to the nearest tenth. Find the length of CD to the nearest tenth of a meter. So first let's identify where is CD. So we can go ahead and look at that. Okay, yeah, I see CD. So let's see how we're supposed to get CD. Take a moment to look at it, and they're like, okay, yep, that works. So first we want to find ED. So that is because we only have stuff given on the bottom triangle. We don't have much given on the top triangle. So after we find out some information about the top triangle, we can go ahead and do something. So the only way to find ED is by cosine law. So let's go ahead and do this. So ED squared is equal to 2.5 squared plus 3.9 squared minus 2 times 2.5 times 3.9 times cos of 97.4. So your calculator should be able to process this all in one step. However, if it can't, just record down some values. So let's go ahead and calculate. Right. And then remember, after you calculate the value, go ahead and square root that value. Because remember, square root. So now, after a little bit of calculations, I'm sure you were able to find it. So remember, I don't really like to round here. So I want you to save that value. For me, that value was 4.89607126. So I want you to save that value and see how we can use it later. So now we're going to go ahead, instead of writing the actual value, I'm just going to write ED as a placeholder. So we can find out the angle C because we can use the inner angle theorem. Let's do 180 minus 56.7 minus 48.2. So what is the answer? 75.1. Right? Yep, 75.1. So 75, so sine, okay. So now let's go ahead and use sine law. Sine of 75.1 degrees over ED. It's going to go ahead and give us, we want CD, right? So we want CD, and this is sine of 56.7. So remember that value you saved from your calculator earlier? Let's directly multiply that by 56.7, sine of 56.7. Multiplying it by sine 56.7 degrees. And after you do that, let's divide by sine of 75.1 degrees. Now, let's look at your value. So for me, my final answer is 4.234554764. However, now we can finally round it because we have done the whole math again. So now let's do the 10th of the meter, so 4.2 meters. So let's go ahead and write our conclusion. CD is equal to 4.2 meters. And with that said, we have completed the lesson. Now, let's go ahead and do some practices. So these are the only practices that I actually want you to do, simply because, look, this looks 2D, but really it's 3D. So I want you to guys go ahead and find the 3D, well, do some 3D practice problems, because it's going to show up in the test, and we all know it. You know it, I know it, we all know it. So, before we start, I just wanted to ask if any of us actually remembers, what is the volume formula to find a triangular prism? Right? So many of us do not even remember. So, not hard. It's always it's always your area times the height. So originally you had a triangle like this. So your formula to find the area will be base times height. Right? But now we're going to times your width. If you know what I mean. Right? So this is going to be our formula. I'm going to go ahead and show you how to I'm going to show you how to do 18, and you're going to go do 19 on your own. So 18, let's see. So first we're going to go ahead and find out the values that we need. So first we have this. So over here on this triangle, on the triangle at the face of here. So this is 37.4. However, there was no 90-degree angle. But what if I just draw in a 90-degree angle? Wouldn't that make it a 90-degree angle? Exactly. So this is 37.4 and this is 90. So now we want to find this height. So this is the height we want to find, x. So how do we do that? Cosine law. Well, sorry, SOHCAHTOR. So remember this on the bottom, that was 9. Now we separate it into two perfect halves. It's going to be 4.5 now, right? Because we separate it in the middle. Or not. Well, okay, I'm kind of having trouble understanding this diagram, but... Okay, I guess they didn't want us to solve it this way. Or did they? Base times height. Yeah, okay, I guess they didn't want us to solve it this way. But... yeah, okay, so they didn't want us to solve this way. So what they want us to solve was, we gotta find the height of this first. So 37.4. This is 28.5. This is 37.4. This was 9 cm. So now we can actually complete the triangle. If you don't notice. So let's go ahead and find the top angle there. So 180 minus 37.4 minus 28.5. So that's gonna give us 114.1. So we can go ahead and use the sine law to crack out all the other values. Let's go ahead and do that. Sine of that, it's gonna equal to, so we needed this side. So let's go ahead and find sine of 114.1 over 9. It's gonna equal to, oh wow, it's gonna equal to sine of 28.5 over, let's say, x here. Now let's find x using calculators. Sine of 28.5 degrees, multiply that by 9, divide that by sine of 114.1 degrees. Go ahead and get 4.7. So 4.7. And now we can finally use the SOHCAHTOR to see what's going on. So let's go ahead. So this was 37.4. So we're dealing with opposite over hypotenuse. So sine 37.4 is equal to x over hypotenuse. Sorry, this is h. So height over x. So basically, we're going to use the x value times 37 sine of 37.4. So for me, I actually saved this x value in my calculator. So now I can directly multiply that by sine of 37.4 degrees. And we're going to go ahead and get 2.85739991. That is our height. So finally, we have found one variable of this entire degree, of this entire thing. However, that doesn't matter anymore, because on the top we had the width. So this was the width, that being 15. So width is 15, and then base we had 9, and height we just found. So let's go ahead and multiply that. So we had a 2.85.739991. So let's multiply that by 9. Let's multiply that by 15. So we're going to go ahead and get 385.748992. We're going to round it to the nearest cubic centimeter, so 386. So finally, our answer to 18 should be 386 cm cubed. And that is pretty much it. All of these type of diagrams, they look a little bit, well, they look very abstract, so you need to have some sort of, think abstract, and you can go ahead and solve many of these questions. That's very simple. And anyways, that is all. If you have any questions, please reach out to me. I'll try to help you to the best if I can.